Uh, Lab program 4 is to implement a C program to demonstrate the shift reduce parsing. You don't need to implement a parser, please understand. You should implement a shift reduce parsing technique for a grammar. The grammar is already been given. It is not R symbol, it should be arrow symbol. Okay. The grammar given is this. E produces E plus T or T produces T star F or F, and F produces open parenthesis E close parenthesis, or F produces IT. We should demonstrate the parsing of this string. And please remember, the program is written to parse this string ID plus ID star ID. You can parse any combination of ID plus ID or ID star ID from this particular grammar. The reason is because the grammar can produce only that. It can either produce ID plus ID or ID star ID or parenthesis ID plus ID or ID star ID, like that. Okay, the program is a very simple one. Please try to understand. We have included string.h and std.h. Fine. We have taken k, z, I, j, c. Among that, k, I, j are used for your loop variables, and c is used for a count or the string length of the input string, whatever you give. Fine. Before going further, I tell you, shift reduce parser works exactly in the reverse order of top-down parsing. In top-down parsing, what we do? We start from the start state, replace a non-terminal by appropriate function until we get the string. But here the policy is reverse. We start from the string, means there is an input string. We choose a symbol or a substring from your input string. Symbol or a substring means I can choose only ID, or I can choose ID plus ID. What the idea? This we call it as handle. The handle will be replaced by an appropriate non-terminal. And this step is repeated a number of times until you get the start state. Means now if the input string is ID plus ID star ID. We keep on replacing ID by E, or then E plus E, then uh, like this. We go on until we are left out only with the start state. That is, in our case, it is E. So as to understand the parsing, we shall execute this program and see how the output comes. That's a better way. Yeah, have a look at this. GCC lab 4.c. Okay. This warning because we have used getters, putters and all. So you can ignore this. Okay. Slash data out. Yeah. It's clearly mentioning this is a grammar. This you need to enter the input string. Okay, I'll give the input string ID star ID. Fine. You can give the same input string or whatever it is. This simple one we should use. So we're going to parse this like this. We have stack, we have input, we have action. So actually on the input, we have ID star ID. So first we should shift and here we have 4 actions. Shift means take an input symbol, move it onto the stack. Reduce, when you get an appropriate handle on the stack, replace it by a non. That's it. If you get an appropriate substring on the stack, replace it by a non. Third case is your success, when you get this particular state wherein you get the start state and a dollar. Means the entire input is consumed and we are left out with only the start state. Then we're going to call it as the success. And if at all you are somewhere in between, either you have some more symbols on what you call your input, and you have some handle on your stack, but you don't have an action to perform either to shift or a reduce, and you don't have a next to move from your in your parse table, then we call it as an error. These are the force parsing. That is why we call it as bottom up parsing, as a shift reduce parsing. Means we shift the symbol from input to the stack, we get the appropriate handle, we choose a non-terminal to replace that handle from our grammar. That's what is called as reduce. The shift and reduce keeps on happening. Either one of the situation happens, that you are left out with no inputs symbols and a start state on your stack. Or the second case is you end up somewhere in between. You don't have any further move. That's what we call it as error. These are the four possibilities. So for the given input, you should get this sort of output specifying the steps of shift and reduce. So how this is happening? It's a very simple thing. We shall see the program. Okay. As I told, we have declared K, Z, I, J, C, C for count and rest of it for what we call it as the loop variables. We have three single dimension arrays, four single dimension arrays that we have used. One is A, one is AC, one is STK, other one is ACT. So if you see ACT and AC, ACT is telling all the shift actions. It is going to hold the value shift arrow mark so as to write beside the in place of action shift, shift, shift whenever it is needed. And AC for writing the action reduce whenever it is needed. Fine. Okay. How it all goes, you can see. And AC and ACT for shift and reduce, A for input string, and STK for copying the or reducing the strings. Fine. We shall see. Okay. We have only one function here apart from the main, that is check. The check is the reduce action. Rest all whatever we do in our main is your shift action. As simple as that. Fine. Okay, we shall understand. In the main program, we are printing the grammar that this is our grammar, it produces C plus E star E, open parenthesis C and ID. And we are asking the user to enter the input string. And whatever the input string user has given, that we are reading it into A. It's an array that is been declared. So maximum 16 characters we can, means to say 15 input items can be specified. Okay. And then we are computing the string length of our A, and that is being stored in C. Please remember, C is the count or the string length of your input string. This can help us to go further. Then we are calling a string copy function into which variable? ACT variable. What we are copying? The string constant shift arrow mark so that it can place shift arrow mark in the action part whenever it is needed. Right? Okay. Then we are printing on the screen this particular line, stack, string left, then a tab space, then in between input, then a tab space, and an action. Right? This is just to print. Now the action starts. Have a look at this. We are having a loop. A is initialized to 0, I is initialized to 0, and J is not having an initialization, but here already it is being initialized to 0. Fine. Until J less than C. C is our string length of the input, whatever is given. J less than C. We are incrementing all of to K, I, J. Means to say, we will going to be taking each character from our input. So if at all, in my case, whatever I have given, first it should read I, then it should read D, then it should read star, then I, then D. Correct now? In that sense, here what will happen? See the next statement. E of J. J is pointing to our length of the input string. E of J, that is A of 0 initially, is equal to I, and A of J plus 1 is equal to D. Yes, of course. That's what is that. A of 0 is I, next one is D. That's what we have written. Then that A of J, that is your I, and that J plus 1, that is your D. Both are copied onto a array, that is which array? STK array. Means we are shifting ID from our input to STK, as simple as that. We are just copying from input to our stack. Okay. We are copying from input to the stack, and then at the end we are filling a blank space so that we can get a space between the I after the I. Okay, and then A of J is equal to blank. A of J plus 1 is equal to blank, because after shifting from your input to the stack, those two symbols, that is I and D, both has to be removed from your input. No, so for that reason, we are filling A of j and A of j plus 1. Observe, STK of I, STK of I plus 1 got ID. Now A of j and A of j plus 1, which earlier was having ID, will be placed with blank. After this, we are printing stack A, that is our input. Stack is your stack, A is your input, ACT is your action. What is that action? Shift. Shift with what? ID. Shift ID. Please observe. Shift ID. Okay. This is when you get a ID, you are shifted it from your input to the stack. Okay. If it is not ID, then what is the possibility? Then the only possibility is it should be your plus or star, because your input string can contain ID plus ID or ID star ID. Nothing else it can contain. So for that reason, if apart from this anything else comes, A of j, that is one symbol which we want to stack, and we are filling with a blank, and we are removing that symbol from the what we call input. Sorry, that is from the input. Yeah. This applies even if you have open parenthesis ID plus ID. If you have open parenthesis, that will be anyway pushed onto the stack, and that will be removed. Next, when ID comes, this code will going to apply to shift. So as I mentioned, your main program is performing only the shift action. And to perform the reduce action after ID or after any one of the symbol, we are calling a function called check. The check function is to find the reduce. Reduce will happen when you have ID on the stack that can be reduced with E. Second possibility, you have either E plus E or E star E that can be reduced with E. Got the idea? So these are the these are the possibilities. And one more possibility is this possibility. If you have on the top of the stack open parenthesis E close parenthesis, then that can be reduced with E. So four reduce actions are possible. One is with ID, one is with E plus E, one is with star E, one is from open parenthesis E close parenthesis. This any of these reduce actions can be taken. Fine. Yeah. Now let's come back to our program. Okay. In check, what is happening? AC is an array which we are putting it with a value. What value? Reduced to E. That's it. Okay. And we are running a loop. Z is equal to 0, Z less than C, Z plus plus. If Z STK of 0 is equal to ID, I, and STK of Z plus 1 is D. Means if we have got ID, then we can reduce it to E. Yes, reduce to E. Yeah. So STK of Z plus 1 will be filled with blank. And it's because the stack should be removed, the ID should be removed. Two characters we are removing. In place of that, we are supposed to put only one character, that is E. And after that, we are printing the stack A as well as AC. It is stack, input, and action. Similarly, if you got same loop is running. If the symbol is E plus E, then we are replacing it with an E, and we are removing plus, and we are removing E. These two symbols. It is replaced by E, and plus E is removed from the stack. Similarly, if we got E star E, we are going to replace it with E and remove star and E. Similarly, if we get open parenthesis E, close parenthesis, replace it with E, wherein we are removing next the last two symbols, that is E as well as open parenthesis. In place of open parenthesis, we are putting E, and we are removing this symbol as well as this. Okay, so that's the four possible reduce actions. 1, 2, 3, as well as 4 reduce actions. These 4 reduce actions is taken care by the function check. So your main is doing only the shift actions. Shift your ID or shift any other symbol what you are getting, either a opening parenthesis or a closing parenthesis. or plus or star. This program is confined only to this particular grammar. It will not work for any other grammar because we don't need to also, because your lab program is clearly given the grammar but also the sentence to parse. We are not implementing a shift reduce parser, but we are simulating the shift reduce actions that is supposed to be taken while parsing. Okay, we shall try with one more input. Okay, dot slash a dot out. What was that is given is id plus id star id. Correct. See the number of steps in place, but it works for any possible grammar for this, any possible string for this grammar, whatever is been fine. And if at all you give an incomplete string, you're going to end up in an error. Yeah, let's try it out with that. ID plus. See that it is not able to reduce it, and you didn't got the what you call the start stage. So it's a error in your what you call shift reduce password. But nowhere we have given the message that it's an error or fine. I will stop this meeting here, and I'll send you the meeting ID again. You can join for the program number 5. It's a quick, some 10 minutes programming. That's it. Fine. So I'm stopping it here. Thank you. Thank you for joining.